So this is problem 16 of chapter 8 of Giancoli 6th edition. So the problem is the following. A car engine slows down from a certain initial frequency to a new frequency. And the frequency is given in RPM, revolutions per minute. And they also tell us the time that it takes for this revolution to decrease. So we have initially a certain frequency, Fi, that decreases to a new frequency, Ff. Both are given revolutions per minute, and they tell us how long it takes for this frequency to be reduced. So the first question of the problem is, calculate its angular acceleration. We know that angular acceleration is the final angular velocity minus the initial angular velocity divided by time. With the frequency, we can get the angular velocity. I just have to be careful here with the units because the frequency is given in revolutions per minute, while the time is given to us in seconds. So, good thing is to write this frequency in seconds. And to do that, I get its value, whatever value it's given to us, it divided by 60 seconds. Okay? So once I did this transformation of units, I write here 2 pi of the final frequency minus 2 pi of the initial frequency. These are the values of the two angular velocities divided by time. So this is an easy problem. Let's see the next question. Question B. Calculate the total number of revolutions the engine makes in this time. Well, to calculate the number of revolutions, a good idea is to get the total angle that this engine rotated. And for doing that, we can use the equation that we found. Theta is equal to the initial omega multiplied by time plus alpha divided by 2 t squared. Remember that this equation is the angular version of that old equation that we've been using when dealing with translational motions in chapter 2, which was x equals to x naught, and I'm assuming here that x naught is 0, plus v naught t plus a over 2 t squared. All right, the initial frequency we have, it's given to us. The time that it takes to slow down is given to us also, and the angular acceleration we just found. So from here we get the total angle theta. But what we want to know is the number of revolutions. I know that the angle 2 pi radians means 1 revolution. So this value of theta, which is given in radians, will give us a certain total number of revolutions, which is easy to find.